Hello everyone. So today's topic is about the comparison of abstract classes versus interfaces. The definitions about these two. So an abstract class is a class that cannot be instantiated directly, and they can contain the methods that actually have the code. With implementation, so you can write the blocks of code inside of that method. You can define an abstract class with just the methods in it, and you don't put any specific behavior in each of the method. Right, it is like a base class. So another word for a base class is a parent class that other classes or the child classes can inherit from. So the interface is like a blueprint that it states out all the methods that the implementing classes must follow. And it does not include any implementation like the abstract class. So what about the similarities of both? So both support abstraction, and abstraction is like a key principle in object-oriented programming. It essentially says that you only need to know what a class does. You don't need to know how it does the behaviors. So let's say I have like an interface, for example. You only need to write down the function names or the method names of that interface without writing down all the logics in each of the methods. And they both cannot be instantiated directly, as we discussed, and they are used to define the common functionalities that derived classes must adhere to. And those are from the abstract classes, or the implementing classes must follow if they are interfaces. So a derived class or child class are the words that we use for abstract classes, whereas the implementing classes is the word that we use for the interfaces. Yeah. They are specifically designed for complying with loosely coupled system. And this is a really important, a vital programming concept. And we actually have seen this in this unit if you have done the HD task, which is related to finite state machines. So, with finite state machines, we essentially have a interface, which is a state interface that, we got many states. Let's say we got 5 states, and each of those states must implement the methods defined in the I state interface. So why it's loosely coupled? Well, because if you think about it, a state is independent from another state, right? That's why we got this finite state machine here. Let's say we have 5 states, and state one is independent to state two. It means that in state one, it can have lots of behaviors, but those behaviors must be detached from state two. Yeah. And that is a really important concept in loosely coupled, because we don't want the two states to be tightly related to each other, because in that case, if we encounter an error in let's say stage one, then we gotta go through both stage one and stage two, and in that case, it's really bonky and it's not effective. If we design a loosely coupled system, we only need to look into state one if we find issues relating to that state. All right, so we have an example right here. So the animal class is a abstract class, and this is the dog class, which is a child class of that animal class. So this is a abstract class, and this is the interface. And yeah, the interface of vehicle, and a car is a vehicle, so it can implement the vehicle interface with this drive method right here, whereas this one with the speak method. So the differences between the two. So the first one, obviously, it's the keyword between the two, because with the abstract class, you gotta assign it with the abstract keyword, of course, like this one. And with the interface, you gotta write the interface keyword preceding to the name of that interface. With access modifiers, so abstract class, they supports access modifiers. So what do I mean by that? Well, we can actually see that, this one can be of the protected access modifiers, and it can also be public. It can also be a private. So yeah, the methods defined in abstract classes can have multiple, not really multiple, but each method can have can be of a protected or a private or a public data type, whereas with interface, you don't really have that choice to implement the access modifier, because with this, you can only write void save, and this one is by default a public ones. So you don't have the choice to decide whether it's protected, public, or private. So with fields and constructors, so with the with here, with the abstract class, we can have like this one is a field, right? Or a or a an attribute or an instance variable. And this one is the constructor. So you can really have fields and constructors in abstract classes, but with the interface, you cannot have those. You can only define the methods. And with the implementation with abstract class, as we have discussed before in the definitions of both abstract class, they can have the method implementations, which means they can actually have the code in here, the console.writeLine, for example. But with the interface, they only have this one. So we can't really implement console.writeLine or anything else in this interface right here. So only method signatures or the names of those. Yeah, and also the return type. Yeah. All right. So the last section right here is the use cases of abstract classes and interface. So when do we use abstract class and when do we use interface? So the first one, we can see that if you anticipate creating multiple versions of an entity, it's best to use an abstract class. And we can see right here, so an entity that we're mentioning in this example is the generate method, and this is an abstract method of the abstract class. And you can have like a PDF report, which is a child class of the report parent class, and also the Excel report of the report parent class, and they both have different versions of the generate method. Like for this one, the first version of the generate method, it will bring out generating a PDF report, whereas this one will bring out generating Excel report, which is the second version of the generate method. But let's say with interface, we try to achieve that. We try to achieve having different versions of the generate method here. So we have two defined methods, which are generate and print. But let's say with the PDF report, if we try to implement this using an interface I report here, what we're gonna do is that we gotta also implement the print function. The print method in the PDF class, because interface essentially means that if anything implements that interface, it must have all the methods defined inside of the original interface. So let's say here we have a print method in the abstract class, but we don't need to rewrite that in the PDF report and the Excel report if we don't want to. If we don't want to reuse the print method in both of these classes, then we don't need to rewrite them. We only need to focus on the generate method, which we are creating different versions of it. But with this one, regardless of wanting to re-implementing the print method or not, we have to rewrite them because it's like a convention. And it's like a rule, because if you let's say if you don't write the print method here, it will result in an error. The compiler will tell you the error because you don't implement enough methods in the iReport interface. Right, so for the second use case, if the functionality that you're creating is useful across objects of the same type, it's best to use interface. So you can see through the example right here, so objects of the same type, what I mean in my example, so let's say we want to create many robots, right? Many robots, and so we have a iRobot interface. So this iRobot interface has its implementing classes, which are robot 1 and robot 2. So both of these are on implementing classes of iRobot. And so we can imagine that iRobot is not like a parent of robot 1 and robot 2, right? If you assess them in a hierarchy, iRobot is just the same as robot 1 and robot 2, because I don't think that robot 1 is like a parent class of robot 1 or robot 2. It's just simply that robot 1 is an instance of iRobot, and robot 2 is also an instance of iRobot, so they are both on the same kind of level if you think about it, and if that makes sense. But with the abstract class, what we're going to do is, well, actually we can do the same. It's just the naming kind of things, but you can see that it's obviously not really reasonable here, because with abstract classes, they use the inheritance concept. And with the inheritance concept, it means that if I write that robot 1 inherits robot here, it means that robot 1 must be a meaningful child of robot, right? And robot 1, as we know, robot 1 is not really a child of robot, and also robot 2 is not a child of robot. We got to think about it, because let's say if we got like a feline class that is an abstract class, and we also got like a tiger, which is also a child of the feline class, and the lion is also a child of the feline class. So lions and tigers, they are true children of the feline class, whereas with this one, it's not so it's pretty long, but essentially there's just some naming ones, yeah. And with the third one, let's say if you're designing a small and concise bits of functionality, you can use interface. What I mean by that is, let's say you have like an interface like this, and you got a button which is an implementing class of iClickable, and also same for the link one. And with the interface, you only gotta write the name of the method that is in that interface. So this is void on click, and so with this one we can implement the method right here in the implementing classes. But with the abstract class, if we want to do the same with the interface, we gotta write abstract class, an abstract method right here, and the overridden method right here. So you gotta create like two kind of methods, one abstract and one overridden one. So it's kind of maybe a little more inefficient in terms of memory. And the fourth one I want to mention is that if you want to provide a common implemented functionality across all the implementations of your entity, you should use an abstract class. So what I mean by that is that, with this abstract class right here, let's say it's a payment processor, and we got a credit card processor as a child class of the payment processor one. So with this one, let's say you create an object of the credit card processor, and you want to call the validate method on that credit card processor object, you can also do that, and it will print out this line validating payment, because this one is a child class of the payment processor, so it inherits everything from the payment processor from its parent. It inherits also the validate class. So the bottom line right here is that you can create, of course, many more children classes of the payment processor, and you can call the validate method on the instances of those classes, and it will work. Whereas with this one, you gotta re-implement the validate method in the children classes. So if you want to create a credit card processor class, which implements the iPayment processor interface, you gotta write them explicitly here. So let's say that if you got another class, let's say a debit card processor, which implements the iPayment processor interface right here, you gotta also rewrite the validate class, because as I said before, if you want to implement an interface, then you gotta you gotta define, and gotta put in the logics of all the methods that were defined in the iPayment processor one. So of course you gotta rewrite this validate one, even though it's nothing class specific with this one. Because with debit card processor, we also want to bring out the same line right here, and we were just doing the same over and over again. Let's say with debit card one, we also will have to define this method, and we will write the same as this. So it's kind of code duplication, which is really not a good practice in programming, as we have learned before. But with this one, we only need to define the validate method once, and with the other children classes, we don't have to define this validate method again. We can just call the validate method, and it will use the one inherited from its parent, which is this one right here in the payment processor. So that is essentially everything. So thank you for listening, and hope you guys enjoyed.